Okay, you'll remember back to when we looked at straight lines, they were always written in this format, y equals mx plus c, where m is the gradient and c is the
y-intercept.
fantastic. Then I changed the game on you and I said, well, what about if we have x plus, y plus some x's, like 3 of them, equals a constant like 5. And we had to interpret that either by rearranging it into this format or by using a different method for drawing that line. And the method I gave you was to find the x-intercept and find the y-intercept and join the dots. Do you remember this? Yeah? Good. Just very, very quickly, this particular equation, I would make x 0 to find the y-intercept, and then therefore y would be 5. And then I would make y 0, right, to find the x-intercept, and this would be 5 over 3. Right, 5 over 3, which is 1 2/3. And I just connect the dots. I just found the x-intercept and I found the y-intercept. We're going to use a very similar method to that for parabolas. If I just take this example as my example, x plus 3 and x minus 1, if I was to find the x-intercepts, what do? Make, thank you, y equal to 0. X-intercepts make y equal to 0. Watch what happens. X plus 3, x minus 1. Not a lot happens, right? But maybe from quadratics or solving quadratics, and if you've done your holiday homework, you'll know the answer to this. Answers are
-3 and +1.
brilliant. One person's done their homework. Okay, so on a graph, I'll show you where those coordinates go. Positive 1 goes there, and -3 goes there. I've drawn them on the x-axis because I've made y 0. And the two coordinates, remember, it'll be -3, 0 and +1, 0. Those are the two x-intercepts for this parabola. Okay, how do we find a y-intercept? Thank you. Finding the y-intercept, make x equals 0. Watch what happens. Bracket 0 plus 3 bracket, close bracket, open bracket, 0 minus 1, close bracket. Answer? 3 times -1, which is -3. Go to the y-axis, which is this one, and go to -3. Put the coordinate. So far I've plotted 3 points on the parabola. I need one more point and I can draw the parabola and I'm done. The fourth and final point is going to come from, is going to be the turning point. Now, can anyone look at this parabolas and tell me, in terms of the x value, where the turning point occurs? Actually, not in terms of the value, just describe to me where always the turning point occurs. That's brilliant. The turning point always occurs between the two x-intercepts. Always halfway between the two x-intercepts. And to find halfway between them, and sometimes it's obvious, sometimes it's not, what we do is we use this formula, one of the x-intercepts plus the other one, and divide by 2. So minus 3 plus 1 divided by 2, and that will give us a value of -1, which, so in other words, the turning point is going to be on this line here somewhere. You can work this out. Minus 3 plus 1 is, what's minus 3 plus 1? Minus 2. Minus 2 divided by 2 is minus 1. Hence, that's going to be the line that our turning point occurs on. Once I know that x value, I can substitute that x value back into the equation to find where the turning point is, and my guess is it's at minus 4, but let me just confirm that by doing it. Here's my equation, except it's got a y equals. I'm substituting in minus 1 this time for x. Minus 1 plus 3, close bracket, and then minus 1 minus 1. Minus 1 plus 3, 2, and minus 1 times, oh sorry, minus 1 minus 1, -2. Answer -4, I was right. And I guessed that because of the shape. By the way, this is another point you could choose. You could cross. See that one there? Because it's symmetrical, and it goes across 1 up 1 and across 1 up 4. You can put it a few more plots. Okay, and that would be how you would draw a parabola of the form that's been factorised.